Let's go now to historical development of computer technology. So we have here the generation 0, or the mechanical calculating machines from 1642 to 1945. So it was Wilhelm Schickard, okay, who was credited with the invention of the first mechanical calculator. Okay, this device was able to add and subtract numbers containing as many as 6 digits. And in 1962, Blaise Pascal, 1623 to 1662, developed a mechanical calculator called the Pascaline, okay, to help his father with his tax work. The Pascaline could do addition with carry and subtraction. So this one here, the first figure here is actually our first mechanical calculator, okay, which was developed by Wilhelm Schickard from 1592 to 1635. Then the other figure here is the Pascaline mechanical calculator, which was developed by Blaise Pascal between 1623 to 1662. So these are the generation 0 or mechanical calculating machines. Then the first generation of first completely electronic computer was developed in 1945 to, or between 1945 and 1953. And this first generation computer uses vacuum tube, no? So Jan Atanasoff, okay, has been credited with the construction of the first completely electronic computer. The Atanasoff Berry computer, or ABC, was a binary machine built from vacuum tubes because this system was built specifically to solve linear equations. So the first generation was created using vacuum tube, no? So this one here are examples of your vacuum tubes. This is as big as 1 liter Coke. So yun na nakadako ang imuhang vacuum tube, no? The first completely electronic computer. So what we have here is the Atanasoff Berry computer, or the ABC. So the vacuum tube here is not shown because this is basically the switching area of your Atanasoff Berry computer. So the vacuum tubes are separated from this particular switching area of your Atanasoff Berry computer. Then we have John Mockley from between 1907 to 1980, and Presper Ikrit were the ones who invented the so-called ENIAC. Okay, they introduced the ENIAC in the public in 1964. Okay, ENIAC means Electronic Numerical Integrator and Computer, and it is recognized as the first all-electronic general-purpose digital computer. Okay, so this one here is your ENIAC computer. Okay, Now, this ENIAC computer used 17,468 vacuum tubes, and it occupies 1,800 square feet of floor space and weighs around 30 tons and consume 174 kilowatt of power. So, ingon ana ka kalas sa kuryente ang imuhang ENIAC, no? It has a memory capacity of 1,000 information bits and used punch cards to store data. So this is the first all-electronic general-purpose digital computer, no? The ENIAC. So dako kay ni siya nga klase nga computer. Again, this area here is just the switching board, no? Switchboard of your ENIAC, no? So the vacuum tubes, which is around 17,468, is placed separately from the switching board. Then, the second generation is a transistorized computer from between 1954 to 1965. So in 1948, researchers with Bell Laboratories, John Bardeen, Walter Brattain, and William Shockley invented the transistor. So it is these three scientists who invented the transistor that revolutionizes almost all devices such as television, radios, and even computer. Okay? So because transistors consume less power than vacuum tube, transistors are smaller and work more reliably. The circuitry became smaller and more reliable. So that's the advantage of a transistorized computer. So what we have here is now a complete set of your transistorized computer. Okay? Unlike in your vacuum tube, which was shown earlier, separated ang switching board and your vacuum tube area, no, for that particular computer, for the ENIAC, for example. Okay, so this one here is the first transistor which was developed by the three scientists, no, Bardeen, Brattain, and Shockley. And then this one here was the improvement made in the transistor development. That is in 1941. This is your transistor here. Okay. And then in 1948, it becomes this transistor. In 1955, it becomes this transistor. In 1957, this one. And 1967, this one. 1997, it becomes a very small type of transistor. Okay, so this computer here again is the transistorized computer during or in between 1954 to 1965. Okay, the third generation of your computer uses the so-called integrated circuit, and that is between 1965 to 1980. Now, Jack Kilby invented integrated circuit, or we call it the IC, or sometimes called the microchip. It is made up of germanium. Now, 6 months later, Robert Noyce created a similar device, this time using silicon. And this is the silicon chip upon which the computer industry was built. So the computer revolution using integrated circuit was based on the use of silicon chip. Now, early ICs allowed dozens of transistors to exist in a single silicon chip that was smaller than a single discrete component transistor. Okay? So, discrete component transistor. So, the IC developed by Jack Kilby and then Robert Noyce is smaller than the single discrete component transistor. Okay? Now, this one here is now your third generation integrated circuit computer. Alright? Then, this one here is what we call the integrated circuit or IC or the microchip. Then, we have the fourth generation computer or the VLSI computers. That is during 1980 to 1982. Now, the fourth generation computer uses multiple transistors integrated into one chip. For example, if you have a microchip which is called SSI or small scale integrated, it can store 10 to 100 components per chips. Then, if you have an MSI or medium scale integrated circuit, then it can store 100 to 1,000 components per chip. Then from MSI, it improves to LSI. LSI means large scale integrated, which can now store 1,000 to 10,000 components per chip. And then we have the VLSI, which is now the fourth generation of computer. We call VLSI as very large scale integrated circuit, which can store more than 10,000 components per chip. Okay, so this one here is an example of a fourth generation VLSI computer chips. Okay, so which contains integrated circuit here. Then we have the fifth generation computer, which now uses ULSI, and that is from 1982 to present. ULSI means ultra large scale integration. Technology uses the production of microprocessor chips having 10 million electronic components. And this generation is based on parallel processing hardware and AI or artificial intelligence software. Okay, now this is now the computer that we are using. Okay, so that is the fifth generation computer, which is capable of parallel processing, support voice recognition, understands natural language. So that's the fifth generation computer. So we'll just wait for the next generation, the sixth generation computer, on what will be the features of this next generation or the sixth generation computer system.